they'll use one party to fulfill their agenda, and it's almost like they'll deliberately do things like this, and any pick it, but they'll do things like this to intentionally get the medium, like not the far left or the far right, but the medium voters to swing heavily the other way, because it gives people the illusion that they're actually voting against this tyranny, and it makes perfect sense, and it's very patriotic and very noble. However, give that group 4 years or 2 years or 8 years, and you'll find that the very same agendas that have always been on the table continue without any sort of pause. And if you get completely fed up with the Democrats, finally, then you vote Republican. And so, to me, anybody who thinks that this whole Republican Democrat thing is anything but a false dichotomy, in my opinion, they're the crazy one. But you mentioned Trump getting in. I had predicted before Trump really had even announced that he was running that it would either be Hillary or Jeb Bush, because that's who it was kind of looking like. And of course, Trump steps in, and you have all these people who think that he's not an insider, he's not a career politician, he is a multi-deca billionaire actor though, and somehow he gets a free pass. And to me, it was the only way that they could have gotten the people behind any candidate, would be to have the media completely blackball them. And really, that was the best thing that Trump could have had happen to him, was have the Republican Party disown him and have these media talking heads claim that he's he's an outsider from the secret societies and stuff. And you've got a lot of very intelligent, say, alt-righters who just jumped on that bandwagon and believe it hook, line, and sinker. But at the end of the day, what really has changed in politics? Now, I guess Trump has reversed some of the stuff that Obama has done while he was doing those signing statements and stuff. But, really, I don't see the Federal Reserve going away. I don't see the wars or the rumors of wars going away. And so it's just proof in the pudding, man, that this whole thing with Trump, in my opinion, he's no better than any of the rest of them. He is an insider to the very definition of it. And anyone who thinks otherwise, I think, is really falling for this deception. But that's my 2 cents. Maybe I'm wrong.
Yeah. Well, it amazes me that you were surprised that Trump got in. I mean, the only thing I can say is you must have missed The Simpsons that way, Kay.
Right. Right. Well, and he'd sort of been flirting with the idea of running for president a long time in the media, and it was always a tease. But finally, prior to this election, he did come out and proclaim that he was running. And what can you do, man? It's almost like a Twilight Zone episode of Back to the Future 2 or something.
Yeah, no doubt. All right. All right, well, enough politics. So, Ear, did you get a chance to read the Skype before you came in and got an idea of what we're doing today on the show?
No, I didn't read it, but I'm going to start reading now.
Okay, well, basically, it's just a kind of pick your favorite either ball earth debunks or your favorite flat earth proofs, and that's all part of this preponderance of evidence that goes together. A lot of people are concerned about saying, well, I don't believe the earth is a spinning ball, but I don't think that there is enough evidence to prove that the earth is flat. And of course, me personally, I hear people say that and I'm just like, seriously? Because to me, there's more than enough evidence to prove that it's flat. But like I said, every person has their own criteria that they've got to come up against, and that's a very, very personal choice. And that's why I think that it's good that so many different people have so many different takes on flat earth, because you never know when somebody's going to say just the right thing that's really going to resonate with somebody, and they're going to go, oh my God, I never looked at it that way before, and bada bing, next thing you know, they're a flat earther. So
flat earth is like a box of chocolates.
Yeah, buddy.
You never know what you're gonna get.
Okay, yeah, perfect.
Yep. So anyway, and I put a bunch of suggestions that that I was going to kind of cover in the chat. So I guess we can go ahead and start that out if you guys want me. I'll go ahead and kick off the first one, I guess. And this is, like I said, we're not going to do them in any particular order, but these are just kind of like bullet points that to me are huge, bits of evidence that go towards this preponderance of evidence. And of course, the first thing that I want to talk about is, we all know the basic specifications of the heliocentric system. At least most flat earthers do. Most ball earthers do not. And the first thing that I want to bring up is that, we're told that the Earth is going around the sun. Not only is the Earth rotating at 1,037.5 miles per hour, but it's also going around the sun at 67,000 miles per hour. It's going around the Milky Way galaxy at about 515,000 miles per hour. The Milky Way galaxy goes around the Great Attractor at about 1.3 million miles per hour. And so, I was just looking at that, and it's like, those are some really big numbers. And if you just take the 1.3 million miles per hour around the Great Attractor, and just forget about the 500,000 miles an hour around the galaxy or the orbit around the sun, then you look at that 1.3 million miles per hour around the Great Attractor, and that adds up to a whopping 31,200,000 miles per day that the Earth is traveling, in that frame alone. And of course, there's, like I said, there's 2 or 3 other frames of reference there. It adds up to 11,395,800,000 miles per year. Wow, that's a big number, and that equals 1,139,580,000,000 miles per century. And if you want to take it out to the next millennia, to the 1,000 years, that's 11,395,800,000,000 miles every 1,000 years. And if you consider the fact that 1 light year is 5,878,612,843,200 miles, that just means that over a millennia, the Earth is traveling a minimum of 2 light years. And that's just in 1,000 years. And the amazing thing that I find about that is that in all that time, you can look at ephemeris data or anything else, and what it tells us is that the stars essentially have never, ever, ever changed positions at all. And when you're dealing with that amount of space traveled, it's literally impossible that the skies could never change. And of course, what is the ridiculous answer that we get from the Globers? Well, the reason for that is because the stars are so impossibly far away. And impossibly far away would be a perfect way to actually describe it, because they're so far away, in fact, that they violate several other laws. The inverse square law, not being the least, angular size reduction, which is also kind of an inverse type of function. You look at that and you start doing a little bit of math, and you find out that there's absolutely no way that the sun could even be seen from a light hour away, let alone any other star that may be 400 times larger from, hundreds of light years away, or hundreds of thousands of light years away, or hundreds of millions of light years away, or even billions of light years away. I mean, the prospect of that is so laughable and so utterly ridiculous that it's hard to believe that anybody could possibly, get a PhD in any of the sciences and not, think about that and figure that out for themselves. So for me, that's probably, well, that's the first one that I'm starting out with, is just these ridiculous velocities, the ridiculous amount of miles traveled per day, per year, per century, and yet these stars have never ever changed. And of course, the ballers will come back and say, yes, they have. But of course, we have no measurements of that. Nobody can prove that. And in fact, like I said, the ephemeris data would certainly disagree with that, because according to it, everything just kind of resets and goes back for centuries and millennia. So that's my first one. So what do you guys think about that? And then who's got one that they want to kick in?
Yeah, we can unpack that one a little bit, because there's a lot there. I mean, there really is. The first thing you mentioned is the complete lack of change in the backdrop of stars over all of history. If we were traveling at these sort of rates and over these distances, you would kind of expect to see some degree of parallax sweeping, unchangeable parallax that doesn't revert back to where it was earlier. But you would expect to see sweeping parallax over long periods of time, which means stars that are closer to us should appear to move faster through the sky over time than stars that are further away. And yet, the only amount of stellar parallax they can seem to measure is just very minute changes in the relative position of stars, which I think can be explained very nicely by things like refraction or the perturbation of light rather than this idea of parallax. But, the other huge part of this as well isn't just the motion through space and this lack of sweeping permanent parallax change, but also the angle of our axis. Right, so like all of the North Pole star remaining aligned to our axis remains hinging on our axis pointing at Polaris in spite of all of this orbit. Like you said, you've got lots of different angular changes in these orbits, and it really, there is no sort of way to rectify this in the heliocentric model, because we definitely observe Polaris in the central northern position over, well, since as long as history's been around. Even in the ancient Roman language, stellar Polaris was what they called it, and it was in central position, and that just doesn't work, especially when you see things like the precession of the equinoxes, which hinges on our axis, making a wobble through time. And finally, the other thing I would mention about all this motion is, the Globers, they say that, well, you wouldn't feel this motion because there's no acceleration, it's a constant motion. But that's just ridiculous, because the spin of the Earth, depending on whether it's morning, noon, or night, would completely change up to 360 degrees or up to 180 degrees, your inertial reference frame relative to this entire system. And anytime you've got consistent speed along a curved linear path, there's necessarily acceleration built in. And these curved linear paths are in contrast to one another. The ecliptic plane around which we orbit the sun allegedly is a single plane, but that's offset allegedly 60 degrees to the sun's path of travel, which is also offset to the galactic path of travel. And the fact that these curved linear paths don't ever produce any sort of measurable or noticeable acceleration here on the spinning ball is a testament to the fact that none of these paths of motion actually exist.
Yes.
Period.
Well said. Okay.
And supposedly we are in an elliptical orbit, so supposedly the Earth accelerate and then decelerate around the sun.
Yeah.
Well, that's right.
This is the second law of Kepler. But
Yep.
we know that this is inverse engineering of what is going on, which is that the sun is moving and accelerate and decelerate.
Yeah, I agree. And one thing that I brought up even last week, John, because you and I have brought this up tons of times, and I can't believe, some of the comments that I got, people are acting like it's a stupid point. And that is, when we're being pulled along at 67,000 miles an hour, and 12 hours later we're being pushed along, at 67,000 miles an hour. And in 12 hours, that is a huge change of rate, angular rate. And to me, it's just like, not only would we feel that, it would literally, whip us right out into space, from my way of thinking on it. So to not be able to feel it or even measure it is beyond me.
Yeah, the fact is that it's not just about feeling. There is no any instrument to detect that motion. Because if everything relates to a human feel, well, I can accept that. But there is no any instrument capable to measure that.
Exactly. Even as,
well,
oh, go ahead, John.
Well, I was just going to say, okay, so when the sun is coming up, the Earth should be racing up towards your feet. And so if you were to say, shoot your pistola in the air, the Earth would be racing towards that bullet that you shot in the air. But 12 hours later, when the sun's going down, you shoot your bullet in the air. Really, it should meet the escape velocity pretty quickly. According to NASA, because it should enjoy the benefit of the Earth going in the opposite direction. And you're right, over 12 hours we should experience a complete 180-degree acceleration from 66,000 miles an hour in one direction to 66,000 miles an hour in the opposite direction. So that's a total acceleration of over 130,000 miles an hour every single day. And not only should we feel it for sure, but there should be some sort of scientific way to measure for this, predict and measure with it, and that no matter what, you cannot find any evidence for it.
No, in fact, it's better than that, because you can find a lot of experiments that was made to trying to detect that motion, and all the experiments fail or prove that the Earth is motionless. So that is the better part for me, that all the experiments prove that the Earth is still, completely still.
And they really try and use like a double think on you too when you watch, like Simon Dan did a video pointing out a dearth video, Deep Inside the Rabbit Hole video, and he's saying at one point, he says, and they're making fun of the speed of 2.2 million miles per hour, and he said, to think that we would feel that is ridiculous, which that statement is hilarious. You're like, what? How did you just reverse it from what would normally be the thought process that how would you not feel 2.2 million miles per hour? He just reversed it on people and said, to think that you would feel that speed is ridiculous. We would never feel this 2.2 million miles per hour. Crazy.
Right.
Well, I think there's a big false equivalency in here as well, because the whole idea that an object that's in motion can act as a fixed frame of reference for some other object that's in similar motion, that is true, as long as there's no acceleration in there. So that, like, let's put it this way, there's a big difference between spitting off the back of a pickup truck while it's moving versus spitting off the back of a pickup truck while it's stopped. The apparent acceleration of that spitball going off the back of a moving truck is going to separate from the main body, the primary body, much more quickly than if it wasn't moving. And so this whole idea that, although yes, an object in linear motion without experiencing acceleration can behave as a fixed frame of reference, although that only applies as long as the secondary body is firmly attached to it and is not accelerated in some other direction. And the Earth, if it was moving around like this, you should be able to find evidence for that. But do you see what I'm saying, though? There is a big difference, I think, between an object in motion as a quote-unquote fixed frame of reference and an actual stationary object.
Yeah, and you can say what you want about it, and I've actually showed before by pulling up Universe Sandbox and showing people what real-time Earth looks like, because for those who are out there saying, and I've said it many times before, we're spinning 1,000 miles per hour, we're going around, that when you look at a real-time view of the Earth in Universe Sandbox, which is supposedly showing you the universe, and you can go to real-time, the Earth just sits there, it doesn't even move. There's no spin, and that's because all these numbers that they've attached to it have to be. Right, so this is the problem. This is what we're stating. This is the thing: is that of course we are spinning at 1,000 miles per hour. We have to be, because that has to make the day work. So that's not a speed that can change. If tomorrow they said, "Oh, now you're moving 10,000 miles per hour," or that wouldn't work, because we need to get once around in time for the sunrise and sunset. But when you're looking at it from an overall perspective view, when you're looking at the entire picture, then you can say, oh, well, it would be crazy if we would feel that speed. But it's like, well, no, those speeds have to be. And like Yuru said, they can't be measured. There is no measurement of it. It's just that it has to be in your model. That doesn't make it true. And as I've showed with scaling and variance, the model is a lie. That's not what the outcome, the moon, and they remain, and the observations would remain the same. And that should tell people, not that the heliocentric model is a lie. That's not what the outcome, or the likely outcome would be. What you should realize is that it can be any other number. And once you realize that, then you start to realize that we're talking about mathematics here and not science and not reality. That you're just applying certain distances and certain sizes to these astronomical items, these celestial lights, applying these sizes to them because they have to be that size. That's just the way it works in their model.
Yeah, the scaling and variance argument is very, very powerful for that. And go ahead, John.
Go ahead. Well, I was just going to say to Jaren's point real quick, just because you can make these kind of observations and assign mathematical values to them that work, does not mean that those assumptions and mathematical values are correct. You could make any number of assumptions work, and the math doesn't prove anything but your ability with math, and your observations are sound.
Yeah,
it's
exactly.
There's still people out there that will argue that math is reality, as we know, and other ballers that will continue to try and speak as if, well, but mathematically it works, or oh, but the scientific model does, or the scientific method does include mathematics, and they just don't get it. They don't get that math, number one, is man-made. I mean, so that's a problem, you know.
Yeah, it's
Well, yeah,
man-made
I mean,
and has
there's
some highly peculiar numbers to it too, that always seem to fall in 666s, and these same numbers we see occur time and time and time again. I mean, this whole everything about this reality is basically a mathematical type of construct, which kind of flies in the face of the idea of being this some sort of a cosmic accident, to have such mathematical precision, right?
Oh, that's due to science.
Well, yeah, of course. So, but a lot of people will say, well, yes, sir, we absolutely can measure these velocities. It's like, really? Name one time. I mean, Michelson-Morley failed to measure any velocity. Today, we have accelerometers that have sensitivity that is beyond belief. In fact, the manufacturers clearly state that these accelerometers and type of gyro instruments, fiber optic, laser interferometer type devices, are capable of measuring the rotation of the Earth. They never say anything else about that. Of course, like we've talked about before, it's not the rotation of the Earth that the fiber optic gyros or the ring laser gyros are measuring. It is the rotation of the sky, and that can be proven and has been proven in the past. And frankly, the other thing that is completely non sequitur about, the argument that these ring laser gyros can measure, that they are measuring the rotation of the Earth, is disproved by Airy's failure, right? The other thing is that if this ring laser gyro can pick up a 1,038 mile an hour rotation, then why isn't it picking up the 67,000 mile an hour rotation around the sun, or the 515,000 mile? I mean, we've talked about this over and over